So in this, I'm gonna turn on the AC. Oh fuck. So what I'm gonna do in this video, this is the next episode of the video. So in the previous episode, we completed the manual memory allocation, right? So I say so a lot. For this video, another challenge is for me not to say the word, that word, right? In this video, like I said, coming off from the previous video, we're going to talk about scope in C, right? So I have created. Oh, I just said so. Fuck. Okay, retake. Hello, guys. In this video, we're going to talk about the scope, the features of scope, and what about it in C. So let's start with it. This comes from the this video is also part of a series where I am learning about C, right, with each article from this resource. I'll link this article in the description below, right? Start with scope then. Scope is all about what variables are visible in what contexts. Yeah. So I have a challenge that I should not say scope, right? I should not say scope. It's not scope. I should not say so in the sentence. So let's just start with it. Block scope. So this is the scope of most all variables devs define. It includes what other languages might call function scope, that is variables that are declared inside functions. The basic rule is that if you have declared a variable in a block delimited by squarely braces, the scope of that variable is that block. If there's a block inside a block, then variables declared in the inner block are local to that block and cannot be seen in the outer scope. Once a variable scope ends, that variable can no longer be referenced, and you can consider its value to be gone into the great bit bucket in the sky. I wonder what's a bit bucket. In the CHAD receiver or bit bucket from a UNIVAC key punch. What is that? In computing jargon, the bit bucket or byte bucket is where lost computerized data has gone. By any means, any data which does not end up where it is supposed to, being lost in transmission or the like, is said to have gone to the bit bucket, that mysterious place on a computer where lost data goes, as in the errant byte, having failed the parity test, is ceremoniously dumped in the bit bucket, the computer's waste paper basket. Eric Sandberg's millions of dollars in time and has gone into the bit bucket. Oh, what is this? The CHAD receiver from a UNIVAC key punch. Oh, I see. Was deposited. I understood now. Okay. So once, yeah, an example with nested scope. Let's go. Nested scope. I'm your right way, Darcy. Okay, so hash include studio.h int main void boom int a equals 12, if a equals 12, int b equals 99, printf print the two variables, print two variables. What the hell was that? A b oh, I wonder why I'm feeling sleepy. Print f yeah, d slash n. What was that? I don't know. Yeah, this is okay because the a variable is in the outer scope, that is under the main scope, you could say. But this will show error, not this. this, because B has already exited from the program, not exited from the program, is already exited out of the stack. In the last, if you don't know what a stack is, summary of it is that a stack of plates, imagine a stack of plates, and in this case it will be variables stacking upon each other. So stacking upon each other, when we encounter the block, the curly braces, I think this is called curly braces or braces. When you encounter the block, that's one stack, not one stack. Yeah, that's one stack. This is how I imagine. That's one stack, and that stack is inside the bigger stack, and the bigger stack will have variables in it, like B. B is one variable. Boom. And when the stack is gone, okay, I don't imagine it like that. We have one big stack, and I put A in it, and then I put B on it on top. Then when it exits the brace, the B gets out, because B's use case is done. B is used only in the curly braces, right? Wait, yeah. So only in the curly braces, like this area B is used, but B is used till this, not B. A is used in this area. So this will show error. I'll show you. Compiler error only. Yeah, there you go. B is undeclared. It doesn't know where's B, right? Main.c. There you go. Now we destroy that. Not destroy that. We delete the line. cc main.c, and boom boom boom. 1299. Boom boom. Let's go. Now way to define variables. Another fun fact is that you can define variables anywhere in the block within reason. They have the scope of that block but cannot be used before they are defined. That's pretty explanatory, because printf I, okay, cool, because I was already declared and I already had a value. If you did not, so if you have a value for a variable, it's called initialized. If you have just the variable, it's called declared, right? So right, we then now a print statement where it prints j, the j variable, before it gets declared. A variable should get declared, right? In some other programming languages, you need to initialize it as well, otherwise it will be like it's not undefined, it will be a null value. Sometimes it can be a null value. Most of them, for JavaScript, it's undefined because it's not defined, the value is not defined, right? So in j is equal to 5, in j is equal to 5, but there is a case of hoisting. Okay, I'm not going into the weeds of that. There's a thing where the functions before calling it can be functions where the function is returned. This is side tangent. For the function is returned, before that you can call the function without any functional prototype or anything like that, because the functions are hoisted. I think that's the word, hoisted, hoisted, right? So so the function will be first already read, right? So one scan, in the first scan itself, the function will be read, everything defined will be read, and then the execution will come. So you can put that behavior for variables as well using the var statement. The let doesn't do it. If you use let, it will create a temporal dead zone. I think that's what it's called, temporal dead zone. Like in that line, you can't use this until you reach the let keyword. That variable is dead, right? But in our C case, we don't have any shit like that. If you try to declare it, it will say undeclared because it doesn't know where it is. Now historically, C record all the variables be defined before any code in the block, but this is no longer the case in C99 standard. Variable hiding, I'm not trying that because it's kind of obvious for programmers like us. For any programmer, basic programmer, so if you know one language, if you know Python, you understand why I did not write that. If you have a variable named the same thing at an inner scope as one at an outer scope, the one at the inner scope takes precedence as long as you're running in the inner scope. That is, it hides the one at outer scope for the duration of this lifetime. So I'm going to do that, main.c, and change in this thing, and int I equals 10, right? And I'll just introduce a new scope, int I is equal to 20. So as you can see, he created another variable called I. That's why it's called hiding. If we had not used if you have not used int or the data type, if you have not created another variable, that's technically not hiding. It's not technically, it's not hiding, it's overwriting the variable, right? So I'm a bit sick. I'm not sick, but I'm just, my there's a residue of sickness. You understand? No, I don't give a shit. Anyways, print f, right? D slash n, then I, it prints the, it what, it will print I is the one going to be printed because I is the one it's accessing. I is already in this block, so it will print I, right? D slash n, and do that. So you might have noticed that in that example that I just threw a block in there at line 7, not so much as for or if statement to kick off. This is perfectly legal. Sometimes a dev will want to group a bunch of local variables together for a quick computation, and we'll do this, but let's see. Now, the answers is going to be 20 and 10. The reason being that, like I said, the one variable, the I variable that was declared in the inner scope, hides the variable in the outer scope. So do that. Scope is not that big of a deal in these cases. Next we have file scope. If you define a variable outside of a block, that variable has file scope. It's visible in all functions in the file that come after it and shared between them. Okay. An exception is if a block defines a variable the same name, it would hide the one at file scope. Yeah, this is close to what you would consider to be global scope in another language. So there is a concept called global scope, where if you put the variables in global scope, everything else can access that variable. So yeah, if I do int shared 10, right, and shared plus 100, void func2 void printf shared void right. So int shared equals 10, int main, not int main, that was void main. $110. Now what happened here was the first function modified it by adding 100 to that variable. The second function printed the variable. That's it. Note that if shared we declared at the bottom of the file, it wouldn't compile. It has to be declared before any functions use it. There are other ways to modify them. I modify items at file scope, namely with static and extern, but we'll talk more about those later. For loop scope. Now I really don't know what to call this, as C11 6.0 doesn't give it a proper name. You've done it already a few times in this guide as well. It's when you declare a variable inside the first clause for a loop. First clause of a for loop. For int I is equal to that I will be accessed for all the scope in that. Now in this case is a bad case, if you think about it, because a better way to give this example would be, but he's a professional programmer, I'm just someone who's starting to learn C, but in my opinion I think using braces here was the much better way. So the basic programmer, not basic, the people who are learning starting to C would know that, oh, this whole thing is a scope. What am I talking about? Let's figure that out. Right. In this for loop, the for loop scope, the squarely basis, in this case it's not written, so it will only be accessible for that one line. But if the squarely braces was written for the for loop, then it can be accessed everywhere in the braces. Now in that example, its lifetime begins the moment it is defined and continues for the duration of the loop. If the loop body is enclosed in a block, the variables defined in the for loop are visible from that inner scope, unless of course that inner block scope hides them. This crazy example prints 999 times. Int main void and boom 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 boom. I'm not gonna write that in because it's a bit too easy. The CSpec does refer to function scope, but it's exclusively used with labels, something we haven't discussed yet. More on that another day. There you go. There you have it. It's over. Our article has been read. So I'm gonna end the video here, right? So that was scope. Next video is going to be about way more types 2. This is a bit shorter video. The other one was 45 minutes. This video is a bit shorter because of two things. First, the article was short. Second thing, I am a bit less motivated to make this video, but I just want to not have a non-zero day, to not have a 0 day, right? So yeah.